Welcome to EDU World Space.
In this exercise, we have a block that has a mass of 10 pounds and an initial speed of 4 feet per second. A force F is applied on the block, and the force F is equal to 8t squared pound force. 8t here is the time, and the block is on a surface that has a kinetic friction coefficient of 0.2. And our goal is to find what is the speed of the block, Vf, after the block travels a distance s of 30 feet. Okay, so basically we know that the net force, which I'm going to call Fn, is equal to the mass times the acceleration, and the acceleration is dv dt. Okay, this is Newton's second law, and that's what we're going to use in this exercise. Now notice that in our case, the net force, Fn, is equal to the sum of the forces. So we have the force of 8t squared minus the friction force, which I'm calling Ff. So notice that F is 8t squared, and the friction force is mu s times mg. Okay, this is the formula for the friction force. Now mu s is 0.2, m is 10 pounds. Okay, and 1 pound times g is 1 pound force. So instead of writing pounds times g, I'm going to write pound force. So this is equal to 8t squared minus 2, and this is all in pound forces. Pound force, I'm sorry. So this is the net force. Okay, now in order to find the final speed, I'm going to integrate the force equation over time, so that we can obtain the speed. Then I'm going to integrate again so we can obtain the position. Okay, and then with the information we obtain, we can find what is the speed. Now notice that Fn is equal to m dv dt. So this means that Fn dt is m dv. And now substituting explicitly, we have 8t squared minus 2 dt is equal to the mass. Let me write the units here. So 8t squared minus 2 pound forces, which is 1 pound times g, and g is 32.2 feet per second squared. Okay, dt, and this is equal to the mass, which is 10 pounds, times dv. So I'm going to divide both sides by 10 pounds. So we're left with 8t squared minus 2 times 32.2 feet per second squared divided by 10. dt is equal to dv. So we obtain 25.76 t squared minus 6.44 feet per second squared. dt is equal to dv, and I'm going to integrate both sides from the time t equals 0, when the speed is 4 feet per second, to a time t, when the speed is v. Okay, so we can obtain 25.76 times t to the third over 3 minus 6.44 t this is in feet per second. And this is equal to v minus 4 feet per second. So v is equal to 8.59 t cubed minus 6.44 t plus 4. This is all in feet per second. Okay, so this is the speed. Our goal is to find the speed when the particle traveled, the block traveled a distance of 30 feet. Notice that we don't know at what time that happens. Okay, if we knew the time when that happened, we could simply insert the time into the equation. But since we can't, we're going to have to integrate this equation again in order to find how the distance evolves with time. Notice that dv is ds dt. Okay, this is 5.59 t cubed minus 6.44 t plus 4. And I'm gonna leave the units implicit, so have ds is equal to 8.59 t cubed minus 6.44 t plus 4 dt, and I'm gonna integrate both sides. In the left hand side, I'm gonna integrate from 0 to s, in the right hand side from 0 to t, so obtain that s is equal to 8.59 t to the fourth over 4 minus 6.44 t squared over 2 plus 4t. So s is equal to 2.15 t to the fourth minus 3.22 t squared plus 4t feet. Okay, and when this is equal to 30 feet, we're going to have to solve this numerically. And if you insert this equation into a numerical calculator, you obtain that s is equal to 30 feet when time t is equal to 2 seconds. Okay, now we can go back to the equation for the speed, this one here, and insert the time of 2 seconds here. We have that v is equal to 8.59 times 2 cubed minus 6.44 times 2 plus 4 feet per second. So the speed v is 59.8 feet per second, which I'm going to approximate by 60 feet per second, which concludes our exercise.